Hi everyone. Today we will be discussing about the paper of the year, that is DeepSeek R1, which is creating havoc in the generative AI market. And not just that, it has even broken the US stock market as well. So, what is so special about the paper? What the team has introduced? We will be talking about that in quite some detail. So, let's get started. But before jumping on to the details of the paper, there are certain terminologies that I guess you should be knowing. The first one being, what is reinforcement learning? I am going back to it because I feel that most of the audience might not be knowing the basic concept of reinforcement learning. So, just trying to give you a brief. It is a type of ML only. Like, you have supervised models, you have unsupervised model, then you have reinforcement learning models as well, where AI learns by taking actions and receiving rewards or penalties based on the action taken. The best part being, for reinforcement learning, you really don't require any data to train. While the model is deployed, it learns on its own as the model runs. For example, you're teaching a bot to play a game. The bot tries different moves. For each good move, like for example, it is able to score a goal. You're playing football, it gets a +1 reward. For bad moves, it gets a -1 reward. Over the time, the bot will learn that which moves to play so that it will get a positive reward. This is how the basic reinforcement learning works. What is SFT fine tuning? So you might be hearing this term a lot, supervised fine tuning. So first of all, let me tell you what is fine tuning. Fine tuning a model is the process of taking a already trained model on generic data set and making small adjustments to its weights to make it more specific. Like for example, you took a llama model, LLM, and then train it on a finance data set. Hence, you are now fine tuning it for your use case on finance. SFT is a specific type of fine tuning where the model is trained using labeled dataset. This is very, very important. Now, the third concept that you should know is knowledge distillation. So, knowledge distillation in machine learning is the concept where you're trying to transfer the knowledge of a huge model to a smaller model. So basically, a teacher model, the larger complex model, is getting used and its knowledge is getting transferred to a smaller, simpler model. The results won't be as it is, but what will happen in say 1/100th of the size, you would be getting almost a similar result. This is called as knowledge distillation. So some of the versions of BERT were generated using knowledge distillation. If I remember, Tiny BERT was one of the models that produced quite good results. Now, these are the three key concepts that you should know before jumping on to the DeepSeek R1 paper. Now, let's jump on to the introduction of the paper first that I've summarized already, where they are trying to mention what the model is doing, what this paper is all about, and how they have improved. So, LLMs have been improving rapidly, going closer to AGI. One of the biggest improvements in recent years is post training, a step done after initial model training. This helps the model to think better, align with human values, personalize responses, do all this without using as much computing power as for training. So, this is mentioning about the fine tuning part. A breakthrough came with OpenAI's O1 models, which extended the reasoning process at inference time when the model is generating responses. This means the model takes more time to think before answering, significantly improving its performance. We know that reasoning models came quite recently only. However, one issue that the team has faced is scaling this reasoning ability effectively during real time is an open challenge. So there have been different approaches that has been used. Reward models have been used. So reinforcement learning have a concept of reward models, as I was showing that you get a +1 -1. It's not that easy. You have ML models running to give you a reward. Search algorithms have been used. Monte Carlo tree search, MCTS. I think this is an algorithm that you might be hearing in some of the papers. So far, nothing has matched the OpenAI O1 models in reasoning. Now, what has come into this paper and what has led to the US stock market crash? That is improving reasoning using pure reinforcement learning, meaning you are not using any supervised data. You are just going with pure reinforcement learning and you're using an algorithm called as GRPO. So, I've already discussed about GRPO in quite some detail in my previous video. Just check it out. I'll be giving you a brief in this blog as well, so no worries. So once they started using pure reinforcement learning for improving the reasonability, the trained model called as DeepSeek R10 using DeepSeek V3 base. So this model was released late in December, before DeepSeek was not into the picture also, but DeepSeek V3 was a crazy model as well. Over thousands of RL steps, the model developed powerful reasoning skill, improved its benchmark score, as you can see. I've already discussed this, so skipping this part, and matched the reasoning ability of O1. This is the best part. So DeepSeek V3 has been improved using reinforcement learning to generate DeepSeek R1 zero. Now, the DeepSeek R1 zero, the raw version of DeepSeek R1, has a couple of issues, that is poor readability and language mixing. So it is at times outputting Chinese and then giving English answers. To fix this issue, they got a new model called as DeepSeek R1 using DeepSeek R1 zero. So first model was DeepSeek V3. Then you went with reinforcement learning fine tuning. You got DeepSeek R1 zero. Now you again went with a few more steps: cold start fine tuning, reinforcement learning focused on reasoning, and SFT supervised fine tuning that we discussed in the first go. All these three steps were again added to DeepSeek R1 zero to get to the DeepSeek R1. I will be explaining everything in detail. I'm just talking about the introductory part of the paper, so no worries. So basically, they figured out that reinforcement learning is the way to go to improve reasoning. And one more contribution the paper has done is model distillation. So what they did, as the DeepSeek R1 models are quite huge, I think 670 billion parameters, they tried to transfer the knowledge, the reasoning knowledge of these models to smaller models like Quen 2.5 32B. There are other models also. Quen, a distilled version of Quen 1.5B is also present. So larger models learn better reasoning patterns. Smaller models can inherit the knowledge without needing complex RL training. Hence, using the idea of knowledge distillation, the team released two models first: DeepSeek R1, DeepSeek R1 zero. Some distilled version of DeepSeek were also released, I think to be precise, 6. The major discovery is using reinforcement learning directly to improve reasoning. This was a only this particular concept has led to the US market crash, because before that it was assumed that you require huge amount of data. It was assumed that you require huge amount of GPUs as well. But now with this, you might not be requiring that. Now talking about the entire approach, you first need to understand how does the GRPO algorithm works. So just giving you a brief about how GRPO works, what we do there is, so let's understand GRPO with this example. I have already covered the algorithm in quite some detail in my previous video. You can check that out as well. So assume that there is a bot which is in a maze and has to choose between three paths A, B and C. So what does the bot do? Using the current policy algorithm. So policy is basically a machine learning model that helps you to choose the next action. What action should I take in the reinforcement learning arena? The bot, using the current algorithm, chooses path A thrice, chooses path B thrice, and chooses path C thrice, and got these successful results 2, 1, and 3. Now, once it has passed through multiple number of iterations using the same policy, using without updating the weights of that model, it is looking at the success rate A, B, and C. So here you can see that C is the most successful path. Now, eventually, after running through all this batch of observations, right, it is making sure that it will update the policy, the algorithm that chooses the action, so that it prefers path C more as compared to path A and B, right? But it should not be preferring just path C, because there is a concept called as exploitation and exploration in reinforcement learning, which states that you should be exploring as well, because there might be a case that you might get a better approach if you explore a new path. And hence, after using this batch of observations, you would be trying to change the algorithm in such a way that from path C, if the probability initially was 30% to choose, it should become 50. For example, these are just exemplary numbers. So this is how GRPO works. What it does, it takes a policy, it goes through batch of observations. Using those observations, it then gets a gradient and then eventually update the model. This is very similar to mini batch gradient descent, if you can remember. I'm not jumping much into it, as I've already covered a video on that. You can check that out. Now going back to DeepSeek R1 paper. So basically the team chose two approaches. So the first one, DeepSeek R1 zero, was pure reinforcement learning. Train the base model, that is DeepSeek V3, using pure RL without any SFT data. Uses GRPO algorithm for each question. GRPO samples a group of outputs, compute rewards, and optimizes the policy using a clipped objective with KL divergence constraint. I think once you look into the video, you would be able to get everything. But just remember that you're grouping the multiple outputs and then computing the rewards and upgrading the policy. How does the reward system of this particular reinforcement learning that has been used for DeepSeek R10 looks like? It has multiple facets: accuracy, rule-based rewards for correct answer, mathematical problems are there, format rewarding, ensure the model structures its reasoning process within tags. So there are multiple tags like outthinking tags that are given. So if the output is coming within those tags, it is giving a reward on that format also. Self evolution, the model autonomously improves its reasoning capabilities over time. So talking about DeepSeek R10, the first model that the team trained, they just used reinforcement learning with GRPO algorithm. They upgraded the policy from time to time, and the reward system included accuracy of the result and format of the answer in which they were asking for. Now, as mentioned, there were multiple issues. Language mixing was there with DeepSeek R1. Apart from that, the answer was not readable at times. It was giving gibberish text as well. So in that case, now the team went with the second model, that is DeepSeek R1, which is going crazy right now, that we all are using. Reinforcement learning with cold start. So I'll be telling you what are the different steps that are getting used in this particular case. Enhance reasoning performance and readability by incorporating a small amount of high quality cold start data. So not just using reinforcement learning, before using a GRPO algorithm for DeepSeek R1, the team first of all trained the model with a very small quantity of high quality data, labeled data. So it is very similar to SFT. But in SFT, the data set is quite huge. Here the data set is very small. As you can read this particular explanation for cold start, it acts as a seed to initialize the model, enabling it to start with basic understanding. Fine-tune the base model with thousands of long chain of thought examples to improve readability and reasoning quality. So the example, the data set that was used for cold start data was chain of thought examples. Chain of thought is basically entire reasoning was also shown. So if there was a question like 2 plus 2 minus 4 into 5, it would be showing all the steps and then the final answer. This was the label data set used before GRPO. Then the next step was GRPO, as similar to DeepSeek R10. Another step used was rejection sampling and SFT. After the second step, that is the GRPO, high quality reasoning and raw reasoning data was collected using the model itself. So what we did, using the model that has been now trained on cold start data and RL training, GRPO, rejection sampling happened where we are generating answers from the current model and then rejecting answers as humans were labeling the data. So they rejected the low quality answer and generated the high quality outputs from the model and then used that model for training the model again. So now the first step was cold start, sort of SFT training. Second was RL training using GRPO. Third was getting the rejection sampling data. So letting the model generate some data for us and then choosing the high quality data out of it. Just that, rejecting the bad quality data, then using that data for SFT training, that is supervised fine tuning. As you can read here, what is rejection sampling? For a given input, the model generates multiple responses. Each response is evaluated using a reward function or rule based criteria, whatever. So that criteria, what you call a good answer or a bad answer, depends upon the team. Only the best response is taken. Now, once the SFT training is also done with this rejected sampling data set, again a second round of reinforcement learning was done. So there are 4 rounds of training that happened. Okay, first was cold start data. Second was GRPO based training using reinforcement learning. Third was collecting high quality data using rejection sampling and then supervised fine tuning with that data. And the last one was second RL training, that is again reinforcement learning using GRPO. Now the important question is, why second round of RL training happened for DeepSeek R1? This is a very important question. So I'll be explaining you that after the first round of RL training, reinforcement learning training, the model was strong in reasoning tasks, maths, coding, logic. The first RL stage primarily used rule-based rewards, accuracy in mathematical problems, right? But it doesn't include that how good the answer is, how humane the answer is, how helpful the answer is. It needed to improve in general purpose tasks like writing, role playing, factual question answering. So the first round was more towards accuracy, the second round was more towards humane preferences. So the second round of reinforcement learning focused on broadening model capabilities beyond reasoning. So not just reasoning and accuracy, It was more towards increasing the answers in coherence, harmlessness, helpfulness, etc. So this is how the two models were trained. The first one, that is DeepSeek R1. So this is how the two models were trained. R10 only GRPO, no cold start or SFT. While in case of DeepSeek R1, the more advanced version than R10, cold start was included, GRPO was included, rejection sampling and SFT training, plus second round of RL training was also included. So after this, we got our DeepSeek R1 model. Now coming to the last part of the paper, distillation, that was important part. So objective distill the reasoning capabilities of DeepSeek R1 into smaller, more efficient data. Method fine tuning open source model. So they chose two models, that is Quen and Llama, using curated dataset from DeepSeek R1 only, and got significant improvements in the reasoning abilities. Now talking about the enhanced reasoning via RL, the conclusion. DeepSeek R10 uses pure RL without cold start, achieving strong performances. R1 leverages cold start data plus RL fine tuning, matches O1's performance. Distilled success. The distilled models are also very successful and right now trending on Hugging Face and GitHub as well. They were the smaller models like Quen 1.5 was also able to beat out GPT-4o and Claude 3.5 Sonnet on some benchmarks. Now, what the team has mentioned: future research directions, journal capability, improve performance in function calling, multi-turn interaction, etc. Language mixing is still an issue. So if you have been using DeepSeek in length, you would be seeing that at times the model replies in Chinese. Prompt engineering and software engineering is also required. There is an important section on discussion as well, where the team has mentioned some of the things around unsuccessful attempts that the team had. So one thing that the team has mentioned is that distillation is superior to RL for smaller models. So if you're using a very small model, reinforcement learning is not the key, but knowledge distillation is. Reinforcement learning is resource intensive but may be necessary for breakthroughs. While distillation is effective, advancing beyond current limits can happen using reinforcement learning only, and certain algorithms like process reward modeling and MCTS, which are getting used in other models, showed potential but were ultimately limited by scalability. So one thing that I'm assuming is that scalability is still an issue. As we mentioned here also, RL is resource intensive, and for PRM and MCTS algorithm, the same case they are saying. So with this, we will be wrapping the post up. I hope this summary was helpful for you all, and you try out reading the paper on your own as well. This paper is revolutionary and can go down in the history as one of the best papers. Alongside attention is all you need. So it is of that category paper. So just give it a try and hope this was useful.